Hello guys, I hope all of you are doing extremely well. So today I am gonna show you how I made a cloud architecture using Terraform. So I will actually go through the Terraform file and this architecture at the same time so that you understand better. So here you can see that I have a main.tf file, and to create the architecture I am creating a VPC, I am creating some endpoints, I am creating a load balancer, I'm creating a ECS cluster, and I'm creating some ECS cluster services which will have our task, and our task will have containers and our invoice proxies and all those stuffs. So let's go one by one. So inside the modules, the first thing I have is the VPC. So I will show you the VPC at first. So here inside the VPC, if I go through the file of the Terraform, then you can see that I am just using the default VPC and I am not creating a new VPC here, and I have my public subnets, and I am just getting the public subnet 1A and 1B, and then I am using a dynamic block for generating this public 1A and 1B, or fetching this public 1A or 1B, and then I'm getting all my private subnets, and after that all my security groups of the VPC, and after that the private route table, and yeah, that's all. And then I am exporting all the stuffs. So here the private VPC is this one, public subnets are which have access to the internet. This is my private route table, and yeah, so basically I think I covered all stuffs. And security groups are something which are attached to the resources, which is not a resource by itself, but it's something that is attached to the resources, so to keep secure our resources so that it will only allow the traffic which have access. So this was the overall configuration of the VPC, which I have written all the files inside the VPC here. The next module that comes is our ECS cluster. Inside ECS cluster, we have nothing. We have a Fargate cluster, named the cluster as Fargate cluster, and then created the resource. Endpoints. We all know that the servers which are inside the private subnet, if they wanted to communicate with the other AWS services securely within by using the AWS private network, instead of exposing the network or instead of exposing the traffic to the internet, then there we use endpoints. The purpose of endpoints is when any of the servers inside our private subnet will request something, it will use the AWS global network via these endpoints and go through the services that we want to access and then come back. So in this way your network remains within the AWS global architecture or private network, and it doesn't goes to the internet, so which is a very secure way to access AWS resources from AWS. So here I am creating three interface endpoints. As you can see, there is a difference between interface endpoints and gateway endpoints, but I'm not gonna explain that right now. And then there is also a gateway endpoint, only one. I'm using only one gateway endpoint. So you have seen that I am creating this one gateway endpoint and three interface endpoints here, so that my private substances or instances can communicate with the AWS services privately. Then comes my load balancer. So load balancer is nothing but this one. So as you can see, I have settled my load balancer target group, which is target groups represents this one, which is the underlying or overlying container on the my broker service. So all the tasks inside the broker service will be handled or will be connected to my application load balancer. So that's why this is the target group and this is my application load balancer, and they are connected by a listener. So we can see that this is my target group, this is my application load balancer, and they are both are connected. The load balancer and the target group are connected to each other by a listener, and then we are exporting all these stuffs out. So this was my load balancer, and the rest remains the services. So inside the services I have two service, broker service and helper service, and both have like same file configuration. So if I show you just my services here, those services have a huge file. If I just show you, they are like a little bit bigger. So here in my services, I have, for the broker service, for this one, I have attached a load balancer that I have created already, that I have shown you just couple of minutes ago. So I have attached that load balancer that I have created, and then I have implemented Service Connect configuration for service discovery, and then I have introduced auto scaling so that when there will be lots of traffic, the service can be auto scaled, and then we should not face an outage. And you can also see that all of my broker services and all of my helper services and all the tasks inside these services are distributed along the two availability zone and two private subnets. So that's why if any of the subnets or any of the availability zones goes down, still our servers will be running there, and there's the benefit of a high availability design. So this was the case, but in the case of helper service, we can see that it only have a service connect, but it is not attached to any load balancer. And on the other hand, it also have auto scaling attached to it. So even though the traffic increases, it can actually auto scale from 1 to 2, and this one can scale from 1 to 2 to 3 and all those stuffs. So in this way, we have also implemented auto scaling inside our services. So now I will not let explain much about this architecture, and I will just run and show you how this architecture works. So if I say I execute the plan, so you can see that Terraform is actually have done everything and saying me 14 new resources will be created. So let's apply this. So I have started creating all these resources, and you can see that Terraform is creating everything for me. It will take some time to create all 14 resources. In that time, I just wanted to explain you how the network flow will work. So the client will request, and then it will come to the application load balancer. And as application load balancer is connected to the broker service, if there are 1, 2, 3, 4, 5 instances of the same broker service, it will just distribute the load among the broker service, and from each broker service will have the power to ping any of the tasks inside the helper service. So these all represent the same application but multiple replicas. So here the envoy, which is a part of Service Connect, has the power to automatically load balance stuffs from to this container or this container. So in this way, actually, the things will work. So it will come from via the client, reach the load balancer, then it will get load balanced between multiple tasks of the broker service, and then the broker service will distribute its traffic to the helper service if it need the help of the helper service, otherwise not. So the resources are still being created. So what I will do is just pause the video for some minutes, and we'll come back when the all the resources are being created or have been created. So as you can see, Terraform has successfully created all our 14 resources, and we have to create nothing. It has just created everything for us, every network connection and everything. So now what we will do is go to our AWS Management Console, and then what I will do is go to Canada Central, and here I will go to my ALB, or also I can go to my Elastic Container Service, doesn't matter. And inside here, unfortunately, if I reload again, okay, so we can see that 2 out of 2 tasks is running, 1 out of 1 task is running, but still it's showing in progress. Okay, it's completed right now. So we can see our helper service and our broker service has been completed, and inside this helper service I have the tasks, and here I can see that there are two tasks, and each task has two containers. One is test app and one is the ECS Service Connect envoy. So if you just compare it, so this is our service, and each service has a task, and each task has two containers. So this way we have completed our helper service. On the other hand, if I just go back to our services and come back to the broker service, then we can see that an application load balancer has been attached to our broker service. As we have seen here, the load balancer will be attached to our broker service. And other than that, if I see, there is only one task because we have already shown here only one task. And then we can see that this task also have two containers as usual, because one is the envoy, which will actually help in service discovery or the sidecar. On the other hand, other one is the main broker service application. And now if you just wanted to see these endpoints, then what can we do is open another ECS console. So I will just do is management console, and then I will just go to my region, and then I will traverse my VPC, and then I will come to my VPC and see the endpoints, and if I go to the endpoints, so here we can see all the four endpoints. One gateway endpoint and other three interface endpoints are automatically created for me, and they are working absolutely perfect. So then let's explore all other resources. Mm, so these are our endpoints, and okay, we can also explore our subnets, but we haven't created, we are already using our default subnet. So you can see that this is my VPC, and inside this VPC there are three public subnets and two private subnets, and there are two route tables. One route table is for the public subnet and another one are for the private subnet. And the internet gateway, there is only one internet gateway attached with each VPCs. We all know that. And yeah, this is pretty much all about the VPC. So let's see what is left. Is anything left or not? No, I think everything is working fine. So now I will do is access my load balancer. So here I will go back to services and then come back to broker service, and I will view my load balancer. And here I can see the DNS name of my load balancer. So what I will do is just try to access it, and then I will just say hello, because I know that my application, broker service application, has a hello endpoint. So I am just loading this, and see, we can get hello world. We can also use the health. Actually this endpoint is being used to check the health, but yeah, it's okay. So we can see okay for the health, and then if we access something passport, it will actually generate something unique. So if we access the passport, then we will get the passport of this container, which is this, something like this, which is a unique ID for each and every task. So each and every task will have a passport or a unique ID. So this is that unique ID actually, which I am representing as passport. And the other thing is, so now the all the things I did was directly request was coming up to this point and then going back. So now what I will do is try to access this also from this service. So for that what I will do is I will try to access one special route which is known as ping, and I will say please ping my helper service, and you can see it's being reloaded. And see, we also get the ID, the unique passport ID of my helper service. Now the fun thing is that there are two helper service, right? Or the two, not two helper service, actually one helper service with two tasks. So it should load balance, right? It should actually load balance to these two containers. So we will try to check that. So what I will do is do this request repeatedly, and you will see that this passport ID will be changing and toggling between two different IDs. So you can see that this stuff is actually load balancing the traffic between these two tasks of the helper service. So broker service envoy is distributing the traffic to to the task of helper service, to this task of helper service and this task of helper service. And the last thing which is left is auto scaling, that when the traffic will increase, can our architecture scale automatically or not. So this is the last thing that is left. So let's start it. So what I will do is, mm, I will here I have used the AB, which is application benchmark software in Linux. So what I will do is just copy everything from here, and after copying everything, what I will do is just paste from here, and then oops, I have two HTTP actually, so I will remove one. So now by doing this, we will actually try to see if the scaling actually works or not. So the benchmarking has already been started. So now we will go to our CloudWatch to see if everything is all right or not. So inside the alarms, I am going to reload this. So I am going to go all alarms. Inside all alarms, I can see that I have actually four alarms, one for going scaling out and one for scaling in for the broker service, and another one is scaling out for the helper microservice and scaling in for the helper microservice. So let's go out and see, and if you want we can also see the metrics here also. So it will take some time to generate the metrics, but we can see that the traffic is going up. So it will take some time to generate all those requests. So what we will try to do is come back little bit later so that it can generate all requests, because it's a tiring process to generate this type of request. So we have to wait a lot of time, so I don't want to make the video lengthy, so I will come back within a short period. So guys, I am back. So we can see that we are having a red alert right now, and so if we go to in alarm and then give a reload, so we can see that target tracking service, if I go to this alarm, this alarm is for CPU utilization greater than 70% for 3 data points within 3 minutes. So we can see that our broker service has already reached over 70% of CPU utilizations at a stretch for 3 minutes, and it's in alarm. And so as it is in alarm, so what it will try is to scale containers. So it's completing its action for scaling the containers up. So we need to wait sometimes right now, but soon we have seen that it's an alarm because our CPU utilization of the single, if I just show you, so there is a lot of stress going on this single security group. So it's is very much weak right now and can't handle lot of traffic. So the CPU utilization of this resource is very much high. So what it will do is expand from 1 and become 2, and then try to distribute the load and separate the load between two services, because its alone is not possible to handle lots of traffic. So that's why it include an alarm. The fun fact is My helper services also include the alarm, because the command I was testing was slash ping slash helper, which I already showed is what it was trying to do. It was actually trying to send the traffic from here to here. So lots of traffic is coming to here, and then lots of traffic is going from here to these services, and so it will become from 2 to 3, and it will become from 1 to 2. So we have two beautiful alarms already triggered. Oops, one alarm gone. So let's check our services. Okay. Okay, so unfortunately one alarm gone away because it again reduced. So before creating a new container, it actually gone away. It's So the alarm was triggered, and soon the alarm was triggered, then the CPU utilization of the helper service actually gone down again. That's why we can see that the alarm has gone. So I'm just waiting for this one to complete. And we can see that our computer is already sending a lots of requests to our server. Oh, by the way, I have forgot to say one thing. We have scaled actually, because earlier we can see that there was only one security group, sorry, only one broker service container, right? But now see, we have started with one, and as soon as the broker service has faced a lot of resources or lot of requests, and then it was not able to serve alone, then it automatically scaled up to two. How beautiful it is, isn't it? So that was the last thing I tried to show, and I have successfully shown you that the auto scaling also working perfectly. So the single server couldn't handle a lot of requests, so it scaled from 1 to 2. And see, now two tasks are running. Instead of creating anything, it automatically got created. So, and now even if you actually do like the passport one, so as now there are two servers, now we will get two different things actually. My bad, I have misspelled the route. It will just be passport and nothing else. So now if we repeatedly reload, we can see that it's toggling between the two things, because now instead of one server there are two servers. So when I request from here, it's load balancing between two, that it was doing earlier, like coming here and load balancing between these two. Now as there are also two servers of the target group of the broker service, so it's now distributing them to the two different targets of the broker service. So now that's why we are getting two different things. And if you wait for some long time, then we could also see that this alarm will gradually go, because we can see that okay, nice, we have just now finished all of our testing. So in that case actually we have seen that we have triggered, and now if we wait for a lot of time, then the extra container or the extra server that we have launched automatically will go. But I will just exclude or end the video right now here. So see you another day. Thank you for watching the video. Goodbye.